சார் லிங்க் இன்னொரு டைம் போடுங்க சார்.
ஸோ டெய்லர் சீரிஸ் மெயினாக வந்து இப்போ டெய்லர் சீரிஸ் ப்ராப்ளம் தான் ஃபர்ஸ்ட் ஸ்டார்ட் பண்ணுவோம். ஐடியாலஜி கிளியரா இருக்குல்ல கைஸ்? Okay, fine. Without further delay, let us get into it. Is the screen visible?
Yes, sir.
Okay, yesterday I asked you people to find out the Taylor series expansion of these two functions. Actually, I have given you two functions and I have asked you people to expand this. Okay, can any one of you tell me what is the Taylor series expansion of f of z, that is e to the power z, at z equals 1 at this point? What is the Taylor series expansion? I asked you people to complete this yesterday itself. Kanishk?
Sir?
Yes, what is the answer?
Sir, किया नहीं sir.
Karan?
Sir, Panaras.
Sunita?
Sir, 1 sec, sir. ஒரே நிமிஷம் சார்.
Just tell me how to do it. What are the steps involved in calculating this one?
So Taylor series का formula apply करना है.
So what is the Taylor series formula? What is the Taylor series?
Sir, f of x is equal to f of a plus x minus a by 1 factorial into f prime
F
of a.
of
That's a
z
continue with
equals
x.
plus
Okay. F of g is equal to at which point?
okay. So f of a plus
z minus a.
z minus a. Then
Sir?
yes.
By 1 factorial.
By 1 factorial.
F dash of a
F prime of a
plus z minus a square by 2 factorial. F double prime of a.
plus etc. It goes till z minus a to the power n upon n factorial, nth derivative at a, and it goes like this. Okay, you have the function f of z, and what is the derivative of f of z? What is the derivative of f of z?
The same. E power z.
Yes. Double derivative.
E power z.
Sir.
So the general derivative is also e power z. Okay. Now, can you guys tell me what is the Taylor series of this function at z equals 1? If you guys know the answers for the question that I asked, even the people in the YouTube can post your answers in the chat box. What is the value of f of a? when A is 1?
Sir, 0, sir.
Yeah. You mean to say that e power 1 is 0. Plus, are you getting my question? I am just asking you to evaluate the function f at the point z equals 1.
E.
Same E power 1.
E power 1 plus
E times z minus 1 by 1 factorial.
e times z minus 1 by 1 factorial. Then, what is the next term? Gayatri.
Z minus 1 the whole square by 2 factorial into E square.
Yamini, what is the general term? Nth term. I am asking about the nth term.
Z minus 1 power n divided by n factorial.
Multiplied with
E power n.
e power 1. Okay. Now just tell me z equals I. Ranjana.
Sir.
What is the first term of? You will have to e power I. Then
Plus E power E plus E into
come again the second term. Here I have given you the general formula, that is the general Taylor series. Just look at the Taylor series and tell me what is the second term.
E power I.
Okay. Good. Next. E power I. Then complete the series. Ranjana, complete the series, I said. Sunita.
Sir, E power I Z minus I by 1 factorial plus Z minus I the whole square divided by 2 factorial E plus etc.
It is simply E or E to the power I.
E to the power I. Sir.
Look at, I have given you the statement itself. I have given you the general Taylor series. You will have to substitute the values in it and tell me. What is the general term?
Z minus I the whole power n E power I divided by n factorial.
Okay, class. Now you have this one, right? Now, if I ask you to find out, like, let me just give you another function. Okay, I am giving you f of z. Okay, g of z is z square, and I am asking you to expand this one about z equals 1 and z equals I. Now you just have to tell me how to expand this in a Taylor series at these 2 points. What is the first thing that you have to do, Yamini?
Sir, f of the f prime of the derivative contribution, sir.
Okay. So if we just find out G prime of Z, what is the thing that you are going to get?
2z.
Fine. G double prime of Z,
2.
what is the third derivative?
0, sir.
So from this onwards, we are going to get 0. Am I right?
Yes, sir.
So in general, let us write it as G nth derivative of G is 0 for n running from 3, 4, and it goes. Okay. Now you have this one, right? So tell
Yes,
me, what is the Taylor series of G of Z at Z equals Z equals 1. First, what should you do?
Instead of that, we have to substitute 1 for f of s, g of z, sir. So 1 plus
So it is going to be 1 plus
2 of 2 is 2, sir.
okay 2
2 by 1 factorial, so it is 2 plus again 2, sir.
again 2. So you don't have to substitute this Z minus A and all.
Z minus 1, sir.
Z minus 1, then
Plus f prime of f double prime of z, 2, sir. 2 by 2
which is 2.
factorial.
Okay.
Z minus 1, the whole square.
So if you
Plus,
just make the plus
0, sir, next.
and all other terms are 0. So when you make the simplification, you are going to get 1 plus 2 times of Z minus 1 plus Z minus 1 whole
Z
square.
minus 1 the whole square.
This is the Taylor series expansion of G of Z at Z equals 1. Is that clear, everyone?
Yes, sir.
Yes, sir.
Okay, when you make the simplification, you will of course get that is equal to Z squared. But when you are asked to expand your polynomial in Taylor series about any point, if it is about 0, you will get back your polynomial. Right? If you are asked to expand about some other point, then you will have to do like this. Right? So G of Z at Z equals iota. For this now you will have to do Kasturi.
Sir, 1 இருக்க பிளேசஸ்ல I வரும்.
Only that thing. No other changes will happen. Are you very sure?
1 minute, sir. பார்க்கறேன்.
Your G of Z is Z squared.
Sir, அதையும் substitute பண்ணுங்க, sir.
Okay, substitute and tell me. Even if you know first term, second term, one by one, you tell people in the YouTube, you can also answer. Yes. So you mean to say that first we will have I squared. Good.
Plus 2 times of z square minus I square.
Z squared minus I squared. Are you sure? What is the second term? What is the second term?
2 times of z minus 1, sir.
2 times of z minus 1. Is it 2 times of z minus 1 or some other thing? Of course, we'll have upon 1 factorial. That is there. What is your first derivative?
z, sir.
So you'll have to evaluate your first derivative at the point about which we are expanding. Am I right?
Yes, sir.
So when you evaluate 2z at z equals I, what do you get? 2i. Yeah. Then the next term is what is your second derivative? Evaluate your second derivative at z equals I.
2, sir.
2. Good. Then what do you have?
Z minus 1
upon 2
square.
factorial z minus 1 or iota.
Iota, sir.
So when you do it, you get a minus 1, I squared is minus 1 plus 2i times of z minus I, and 2 and 2 gets cancelled. So we have z minus I whole squared. Hope you get the ideology of how we expand things. Is that clear, everyone?
Yes, sir.
Yes, sir.
Everyone means even the people in the YouTube. I am asking you guys as well. Now we move to the next problem. There are two ways in which it can be done. Okay, I'll explain you the two ways, but I'll explain you the two ways, but I will not work it out completely. The first one is to find its derivatives and proceed with this. The other one is to use the fact that sine z can be written as e to the power iota times of z minus e to the power minus iota times of z upon 2 iota. We know the Taylor series expansion or the Maclaurin series expansion of e to the power z, with which we can solve. Okay, with which we can do, or the other way is to proceed with finding the derivatives of sine z. Okay, now Gayatri, Karan, Prasanna Devi, Ranjana, Sunita, you guys do with this one. Okay, e to the power iota times of z. With this, you just do. Okay, you think how to do it, and you will have to tell me. And Kanish, Kasturi, Rajalakshmi, Sripadi Ayappan, Yamini, you find the derivatives of sine z, and with the help of that, you do the expansion.
Okay.
Am I clear? Okay, just think how to do it. Let me ask one by one. Gayatri. Gayatri. Karan.
Sir.
Okay. So you guys are going to do with this, right? What is the Maclaurin series expansion of e to the power iota times of z? Just tell me for e to the power z, then expand this to e to the power iota times of z and e to the power minus iota times of z. What is e to the power z? Maclaurin series
So
means
1 plus
Taylor series about 1 plus
0. Z by
1
1
plus
factorial
okay
plus z square by 2 factorial, and it moves on up to z power n by n factorial.
After which what happens? It goes on. It is not stopping anywhere. Okay, so from which you can find out these values, right? And that shall be done by Prasanna Devi.
Sir,
Just tell me what is e to the power iota times of z. How do you calculate it? You have that one. From that, how are you going to calculate?
I plus
Sir,
Yes, Gayatri, wait for a moment. The next one you shall answer.
okay.
Yes.
I plus z minus I.
Are you very sure? Have you gone mad? In the place of z, you have iota times of z.
Yes, sir.
I'm just asking
1 plus
you.
zi
Yes. Proceed.
by 1 factorial plus 1 I z per square by 2 factorial plus etc. I z power n by n factorial plus etc.
Gayatri.
Sir, excuse me, sir.
Sir,
Yes.
Sir, I had a severe head pain. Class கவனிக்க முடியலைங்க sir.
Okay, you can leave.
Thanks.
Gayatri.
sir,
Yes.
1 minus I z by 1 factorial
Hmm.
plus I z the whole square by 2 factorial
Just write as it is so that it will be easy for us to calculate. Okay, what would be the third term?
plus minus I z the whole cube by 3
And the
factorial
fourth term is
minus I z the whole power 4 by 4 factorial plus still minus I z the whole power n by n factorial.
is it clear till this?
Yes,
Yes,
sir.
sir.
Okay. Now what we can do is that we can just subtract these two things. So when you are about to subtract these two things, you will have to do it term wise. So just subtract these two things. 1 minus 1, what you are going to get?
0.
Okay. Next, when you subtract, you have this common term 1 upon 1 factor. You have the common term 1 upon 1 factorial. You take it outside. You have iota z minus of minus iota z plus 1 upon 2 factorial. Whether it is plus or minus, when you make the even power, that is the same thing. Am I right? So it is going like this. So what would be the second term?
1 by 1 factorial into 2 iota times z
2 iota times of c. Okay. And the third term is
plus 1 by 2 factorial into
Minus z
minus e square. Okay.
minus 2 z square.
Are you very sure? Do the calculation properly. Even the people in YouTube, you may answer this. What is this?
zero square.
0.
0. So next term is next term would be, if I'm not wrong, I is e to the power 3 minus times of minus I is e to the power 3. This is what we will have. Am I right?
Yes, sir.
Okay. So the fourth term would be 1 upon 4 factorial I is e to the power 4 minus I is e to the power 4 plus 1 upon 5 factorial I is e to the power 5 minus I is e to the power 5 plus 1 upon 6 factorial I is e to the power 6 minus I is e to the power 6, and it goes like this. Okay. Tell me what is going to happen with the third term. I mean, the power 3 term. What do we get? Yes, Ritika, Madhumita, Sanjita, Renu, put
Minus 2 z cube.
minus 2iz cube. Good. Plus 0 minus 2iz cube Then the fourth term, that is this term 1 upon 4 factorial, this term becomes and anyway, Ritika has answered it already. All the even terms are 0. Tell me what is going to happen with this 5 factorial term. Something upon 5 factorial. What is that something?
So 2i z power 5.
2i z power 5. So from this, now you may get some generalization that you have 2iz minus 2i z cube upon 3 factorial plus 2i z to the power 5 upon 5 factorial. Then you would get minus 2i z to the power 7 upon 7 factorial, and it goes this way, right? When you divide this quantity, that is e to the power iota times of z minus e to the power minus iota times of z upon 2i, all the 2i terms gets cancelled, so you are left with z minus z cube upon 3 factorial plus z to the power 5 upon 5 factorial minus z to the power 7 upon 7 factorial plus etc. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
This is one way of obtaining the Maclaurin series expansion for this case. The second way is to proceed with direct derivative, right? For which I would like to call Kanishk.
Sir.
You have the function f of z is sin z. What
Sir,
is
we have
its
to find first
derivative?
derivative. Cos z, sir.
Cos z. Then the second derivative
Minus sin z.
minus sin z.
Then minus cos z.
Third derivative.
Minus
Okay.
cos z.
Then fourth derivative
Plus sin z.
plus sin z. Fifth derivative.
Sir, cos z.
So the repetition would take place. Am I right?
Yes, sir.
The same thing, but we'll have the repetition. If I'm not wrong, am I right?
Yes, sir.
Okay, fine. So now, Kasturi,
Yes.
since we are evaluating at z equals 0, tell me what are these values? What are these values?
The sin 0,
Okay,
1,
1,
0,
0,
plus 1,
minus 1,
0, 1.
0, 1. So when we write it in this one, so this is the general thing. F prime of z naught upon 1 factorial multiplied with c minus z naught plus f double prime of z naught upon 2 factorial multiplied with z minus z naught whole square, and it goes like this. So when we substitute here, we get sin z is 0 plus 1 multiplied. So when you simplify it, you are going to get the same thing. Guys, is this clear?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Guys, is this clear?
Yes, sir.
Yes, sir.
Okay. Can you guys find the Maclaurin series expansion of cos z. If you know the answer, you just tell the answer. You don't have to worry about how we get this.
1 minus
1 minus, good.
Z square by 2 factorial.
Okay.
Plus z power 4 by 4 factorial. Minus z power 6 by 6 factorial. Plus z
etc.
power 8 by etc.
Okay. So we just write it as etc. Okay. Now, whenever we write Taylor series expansion or Maclaurin series expansion, we'll have to specify the region in which it is valid. Okay. So here we have found for many things. Do we have any restriction on z? Like we have to take z only from this region. We cannot take it from some other region. Do we have any restrictions of that form? Or we do not have any restrictions like that? Okay, we have seen several examples today. In all these examples, do we have any restrictions on z?
No, sir.
No. Okay. So till now we have considered about 4 different functions. Can you tell about the analyticity of all these 4 functions? Even the people in YouTube, you can answer this. We have seen 4 different functions. What is the analyticity? Or do we have any points in which the function fails to be analytic for these 4 functions? Sanjita, you mean to say that we do not have any points at which the function fails to be analytic? What is the domain of analyticity of all these 4 functions? This is my question. Hope the question is clear now. Sripati Ayappan, is my question clear? Sripati Ayappan, is my question clear? Is my question clear?
Repeat it once more.
I am asking you to find the domain of analyticity of all these 4 functions. Or in other terms, do we have any singularities for these 4 functions? So I'll just write down all the 4 functions that I have given you here. The first one is e to the power c. Second one is z squared e to the power 3z. And the third one is sin z. And the fourth one is cos z. Shivashankari, Ranjani, Priya, Shruti. Yes, good. I haven't received any response from the people in Meet.
Sir, no singularity.
Yes. All these 4 functions has no singularities. So we'll have to specify, whenever we write Taylor series expansion, we'll have to specify in which region it is valid. Okay. For all these 4 functions, we have expanded about several points. For all the points, this is the region in which the Taylor series expansion is valid. Okay. In other words, all these 4 functions are entire functions. right? So by entire function, we mean that it is analytic everywhere in the complex plane. So all these four functions are entire functions. So it does not admit any point of singularity, right? Now, with the ideologies that we have learned, we are moving to the next problem. F of x is hyperbolic sine z. Okay, for which you will have to calculate. So the first one is hyperbolic sine z, and the second one is hyperbolic cos z. And let me give you an idea as well. Okay, so the result, well-known result is hyperbolic sine z may be written as iota times of minus iota times of sine iota times of z. And similarly, here your hyperbolic cos z is cosine of iota times of z. We have these two results. So with which can any one of you tell me what is the Maclaurin series expansion? I'm just asking for Maclaurin series expansion or anything else. Rajalakshmi,
Sir?
you try the second one.
Yes.
I have given you the idea as well. You don't have to differentiate and do the things.
Sir, z by 1 factorial plus z cube by 3 factorial.
So what function you are saying, sine or cosine?
Sir, sine h
Okay,
is
you are saying for sine. Okay, fine, good. So for sine, you are telling the answer or you are just telling the expansion of sine z?
sine h is sir. Hyperbolic.
Okay. What is it?
Z upon 1 factorial
Okay,
plus c cube upon 3 factorial
good.
plus c power 5 upon 5 factorial.
5 factorial and it goes on. Yes, good. This is the Maclaurin series expansion of hyperbolic sine z. Okay. Now, Rajalakshmi has given us the answer. Can any one of you tell me the steps involved in arriving this?
सर पार्ट का डिफरेंशिएट करना है क्या सर डेरिवेटिव
डिफरेंशिएशन करने की जरूरत नहीं है यहाँ, क्योंकि हमें तो साइन सी का एक्सपेंशन पता है ना,
सर
उसी तौर पर हम जा सकते हैं. Plus, we have just seen the Taylor series expansion, that is the Maclaurin series expansion of sin z. What is it?
Z by 1 factorial minus 1 by 3 factorial plus Z power 5 by 5 factorial
Minus z to the power 7 upon 7 factorial, and it goes like this. Okay, good. So I have given you this result. It means if you just find out the Taylor series, that is the Maclaurin series expansion of this quantity, and you just multiply that with minus I, then you are done. Is that clear?
Yes, sir.
Okay, what is sine iota times of z? You will have to just substitute this here. In the place of z, you will have iota z. Is that clear?
Yes, sir.
So from this, you try to take iota outside. So you will be left with z upon 1 factorial. Here, iota cube means it is minus iota. So minus times of minus iota becomes plus iota. We have taken iota outside. So we have z cube upon 3 factorial plus here iota power 5 means it is plus. So we have taken that iota outside. So z to the power 5 upon 5 factorial and we have everything positive inside. So we just multiply minus iota with this. So when you multiply minus iota with iota and then z plus z cube upon 3 factorial plus z to the power 5 upon 5 factorial plus etc. Iota with minus iota becomes 1. So this is it. So in a similar way, we can calculate here as well. Now, can anyone of you just tell me what is going to be the Taylor series expansion of this one? Sorry, Maclaurin series expansion.
1 plus
1 plus z squared by 2 factorial
the square root 2 factorial plus z squared by 4 factorial plus factorial plus etc.
Is that clear?
Yes, sir.
Okay. So if you know Maclaurin series expansion for one particular function, with the help of that itself, you can expand the other things if you know the equalities or results concerning all these things. Right? Now we just move to the next example. Okay, even for the previous one, these two are also entire functions. Right? We have the result that algebra of entire functions is an entire function. So with that ideology, we can easily prove that these two are entire functions. Therefore, the region of convergence is absolute of z smaller than infinity. That is going to be the region for this case as well. Now, coming to this, what is the Maclaurin series expansion? Any idea or how to do it? So let us take this as the function f of z. So let us go by the usual way. What is the derivative?
Minus 1 by
1 by
z
Are you
minus
very
1.
sure we'll have minus? Okay, minus 1 upon 1 minus z whole square. Then are you people sure about
minus.
this is the derivative? Yes, this has to be multiplied with minus 1. Why?
So it's a function of function.
So we have 1 upon z. So first we'll have to differentiate as it is and then 1 minus z. So when you differentiate 1 minus z, you would get minus 1. So it is simply 1 upon 1 minus z squared. Okay, what is second derivative? What is the second derivative? If you want, I can write it in the most convenient form. Is it convenient now to differentiate?
minus 2 by 1 minus z whole cube.
1 by the whole power minus 3.
So minus 2 multiplied with 1 minus z to the power minus 3. Then
minus 1, sir.
minus 1. So this is 2 times of 1 minus z to the power minus 3. Okay, fine. What is the third derivative?
Six into
1 minus 3
Good. Fourth derivative?
18 into 18
Yeah.
into 1 minus.
Wait. I have made a mistake.
24.
24 into 1 minus
C.
minus 5.
That is 24 times of 1 minus e to the power minus 5. Now, tell me,
So n factorial.
so with this, you can generalize.
N factorial.
So you
1
mean to
minus
say that
z
we have n factorial. Okay, n factorial.
into 1 minus z minus of n plus 1.
So this may be written as n factorial upon 1 minus z to the power n plus 1. Am I right?
Yes, sir.
So we have the general case, so with which we can expand. Okay. So if you are asked to find out the Taylor series expansion of this function about any point z naught, then you would get what? F of z naught plus f prime of z naught upon 1 factorial multiplied with z minus z naught plus f double prime of z naught multiplied with z minus z naught whole square upon 2 factorial plus the derivative. It goes like this, right? So here we'll have to just find out about z equals 0. That is 1 upon 1 minus z at z equals 0. What is the value?
1 plus
1, sir.
1 plus
1
you have
minus
your
z.
sorry
1 minus
1 plus 1 plus what?
So z by 1 factorial.
So 1 plus z upon 1 factorial. It is just that if you see, this is your general case, right? So if you put n equals 1 in this, you will get 1 factorial upon 1 minus 0 to any power. Here, you remember that you are expanding things. This we can find, right? We are about to evaluate at the point 0. So when you find this, you would get simply n factorial upon 1 minus 0 to the power n plus 1, whatever may be the value of n. This is simply n factorial, right? So this is the term that you need in Taylor series expansion. Am I right?
Yes, sir.
yes, sir.
So whatever may be the value of n, you are going to get 1. So it is simply 1. We have found nth derivative at 0 upon n factorial. For all values of n, you are going to get only 1. So 1 multiplied with z minus 0 plus 1 multiplied with z minus 0 squared plus 1 multiplied with z minus 0 cube, and it goes this way. Is that clear?
Yes, sir.
So it is simply 1 plus z squared plus z cube plus etc. till z to the power n plus etc. This is what. So this may be written as summation n runs from 0 to infinity z to the power n. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now you will have to find out the region of convergence for this power series. Do we have any singular point for this function?
Yes,
Yes, sir.
Point 1.
What is that?
1.
1, sir.
1. So if your region consists of the point 1, then the Taylor series expansion is not valid. Clear?
Yes, sir.
Sir.
So you will have to find out the here when we say about the region of convergence, we look for the largest possible region in which it is valid. So in the case, we must not include z equals 1 means here we will talk in this sense only. So if you include 1, then you have the singular point. So we'll just omit that 1. So the region of convergence for this case is this one. Is that clear?
Yes, sir.
Fine. Now, in the same thing, with the idea of the same thing, I want the Maclaurin series expansion for this function. What can you do? Do you have any ideology or any substitution technique by which you can find this without finding the derivatives and all?
We will get alternative plus and minus.
1 minus z
Okay.
z square.
Okay, so we would get that one. Okay, how did you get that? You don't have to make use of any other ideologies. You just look for the previous Maclaurin series expansion that we have got. With that, we can do it. Is it possible for me to write this as 1 minus of minus z? Can I write like this?
Yes, sir.
Yes, sir.
So, this is summation n runs from 0 to infinity. Instead of z, I'll have minus z to the power n. With instead of z, I'll have minus z smaller than 1. So, which means summation n runs from 0 to infinity minus 1 to the power n, z to the power n with absolute of z less than 1. Be it absolute of minus z or absolute of z, we are going to have this one. Is that clear?
Yes, sir.
Yes, sir.
Okay. So, having all these things, now I am going to give you an exercise which is to be discussed in afternoon's problem solving session. Of course, for afternoon also, you people will continue. Right? So, mainly I'll ask you guys only. I have one representative from all the teams, so you can discuss with your teams to get these problems done. Identify the Maclaurin series expansion of this function at z equals 1. Okay? And this is the first problem, and the second problem is to here, remember that you cannot expand the second function about z equals 0 because z equals 0 is a point of singularity to this function. So at the point of singularity, one cannot obtain Taylor series expansion. Right? So for which, what you have to do is that I'll give you the ideology as well. So you try to get this maximum power outside. So it is 1 upon z cube multiplied with 1 upon this one upon 1 plus z squared. So you have this one, right? So do some calculations and write this in this form. Okay? You just see how to get this one. And you can obtain the Maclaurin series, Taylor series expansion for this function. Right? So try this one first. First problem you can easily complete. The second one you just give a try that we will see in the afternoon session. Thank you.